going to be looking at obtuse angles. We're going to talk about, and if you guys have noticed, this is a graph that we're used to looking at, but I've split it. I've really only used the top half of the graph. Okay, and we're going to focus on quadrants. Quad essentially means four, and there are 4 parts to these graphs. We're going to look at quadrant 1 and quadrant 2. These 2 quadrants deal with what are known as acute angles and obtuse angles. Okay. Now, the way we make these is the idea is if we were drawing a circle, okay. So let's say I used this line and I was tracing the outside. I can build a circle all the way around here. And no matter where I stop with this, I can build a right angle triangle from it by just drawing a line directly down to the x-axis. Okay. If I were to do that, I would create a 90-degree angle, and this would be the angle I'm looking for. Okay? The angle I'm looking for in here, maybe we call it x in this case. So, any angle I make in this quadrant here, whether it's down here or I go very high, is going to be an acute angle. The reason being is from the starting point here to our ending point would be 90 degrees. Okay? So no matter what, where, or whatever point I use in quadrant 1, okay? And if you guys notice, I've used a specific point for this question here. This is at 7 and 4. Okay? So if someone gives me a coordinate, you're at point 7 and 4, what would the angle be from the origin? We would create a right angle triangle from there. We would plot this point, draw a straight line down, and then connect the line from the origin. That would create a right angle triangle, and then we could solve for whatever acute angle is in here. Once we've done that, I need parts of the triangle. I need to know how long certain sides are. Does anyone know how long this side is? It's 4, that's right. It's the height. Okay, so this is the idea of the y. So the height of any of these triangles will be the coordinate of the y. And what about the base of this triangle? That's right. It's how long we've gone across our x-axis. So now what we've done is we've created a right angle triangle that we know is 7 and 4. I now have enough information to help me solve for the acute angle in this triangle. So if we get any points in quadrant 1, we can solve for it, and it will be an acute angle. Okay? And in this quadrant, everything we use will be positive. Whether we use our sine ratio, our cosine ratio, or tangent, every answer we get will be a positive angle. Okay? Which brings us to quadrant 2, where things change a little. So quadrant 2. Anything past this point here is greater than 90 degrees. Okay? So anything over here is less than 90 degrees. Anything in quadrant 2 is greater than 90 degrees. And an obtuse angle falls between 90 and 180. So all of our angles in quadrant 2 will be between 90 and 180 degrees. The problem is when we go to solve for these angles. So let's say, again, we've been given a coordinate that's in quadrant 2. We'll do it purple here. We've been given this coordinate at -5. Oh, I don't want to use 2 numbers that are the same. Let's say -5 and 6. Okay? So they've given us this point at -5 and 6. Okay, so I have that point. I connect the line to the origin, and then I draw a line directly down to create a right angle triangle. I now know this is a right angle triangle, and I know parts of the triangle. What is the height of this triangle?
It's 6.
That's right, 6. Now, how long is the base? Is it -5? Can we have a negative length of something? It's technically 5. Now, you're right, we did go backwards, and that -5 is going to play an important part here. If we go about doing this and solving for this angle here, we're not actually solving for the angle we're looking for. We're just solving another acute angle. Okay? the real obtuse angle has to start from the origin. So we're looking at the angle that goes all the way around. So the rest of this angle. So the rest of this angle means that we'll have to find whatever this angle is and subtract it from what value to find the unknown purple obtuse angle. Does anyone know? That's right. So let's say this was 45 degrees. We would subtract it from 180 to find out what the obtuse angle is. Now the only thing is in quadrant 2, anything we use sine for will be positive. Anything we use CAS, yes, good. Anything we use cosine for, all of our answers where we have to use cosine will be negative. And any answer that we have to use tangent for will give us a negative answer. Okay? So I want you to get used to this on your calculator. Before we even go into it, we've only talked about ideas. Let's actually go about plugging in some of these values. So to get used to this idea, I know this seems very abstract to start. I want you to find in our first triangle, so we'll call this triangle 1, I want you to find sine of angle x, so that means you have to find angle x, cosine of x, and tangent of x. Okay? And tell me what values you get, what ratio, so they'll give you some decimal. And in quadrant 2, or triangle 2, I want you to find sine of x, which means you'll have to find out what angle x is, cos of x, and tangent of x. Okay? I want you to go about plugging all those values in and seeing what types of answers you guys get. So, okay, so I wanted you to try to find this angle. I'll walk you through that, but I'm going to go through it relatively quickly. We already set up this right angle triangle. We know that this height is 4 and this base is 7. So with that being said, recreate this triangle very quickly. This is 4, this is 7. We're looking for this angle here. That means I have the opposite and the adjacent. So I'm looking for tan x, which is equal to 4 over 7. To solve x, I need tan inverse 4 over 7. We've already gone through this. So this angle here, 4 divided by 7, inverse of 10, 29.7, we're going to call it 30 degrees. It's approximately 30 degrees. Okay? In the other triangle, we're looking for this angle x. Okay? Now the height of this one was 6, and the base was -5. Right? But we know the length of a triangle, we're going to use the absolute value. So we're going to use the value of 5 itself. That's what's important. We set it up the exact same way. Tangent x is equal to opposite is 6, adjacent is 5. X equals tan inverse 6 over 5. What did you get? 58? 50.1. Okay, so we'll say it's 50 degrees. But remember, we're looking for the obtuse angle in this question. So we're looking for the rest of that angle. We found the angle inside of the triangle. So in order to find this obtuse angle, what do we do with this angle? We have to subtract it from a certain amount. That's right. 180 subtract 50 gives us 130 degrees. So this obtuse angle is actually 130 degrees, while the acute angle was 30 degrees. So we found this information. This is 30. This part here was 130. I want you to take these values and plug them in. So sine 130, cos 130, tan 130. Sine 30, cos 30, tan 30. They're going to give you decimals when you type your into your calculator. So let's say 30 sine 0.5. 30 cos 0.866. And tan 30 0.577. Okay, all very different ratios. And that's because they refer to very different parts of the triangle, right? Sine is opposite over hypotenuse. Cos is adjacent over the hypotenuse. And tangent is opposite over adjacent. So we get very different ratios when we divide those. Okay? And you'll see that these are actually equivalent, these ratios, to those sides of the triangle. Does anyone know what the hypotenuse of this triangle was? 8 point what? It was 8 on the dot?
Yeah, 8.06.
Okay, 8.06. So if we were to set up sine ratio, sine being opposite over hypotenuse, that's 4 over 8.06. And if you divide those, or roughly 8, you should get about 0.5. So we are looking at the value of 8. For our adjacent, we're looking at 7 over 8. I'm going to say we rounded it to 8, because we know that'll give us 0.5. And for our tangent, opposite over adjacent is 4 over 7. Those ratios all work out. For our obtuse angle, it's a little different. 130 sine is 0.766. 0.766. Well, what does that refer to in our triangle? Sine is opposite over hypotenuse. Does anyone know what the hypotenuse was to this one? 7.9? 7.8? Okay. So in other words, we should be able to divide 6 over 7.8. And we get a positive value, which is going to be important for us. 130 cos is negative 0.64. And the reason for that is because cos is adjacent, and the adjacent in this side is a negative value. So negative 5 over 7.8. So we get a negative answer when we put this in the cos. And tangent 130, negative 1.19. And the reason, again, is because we're opposite, which is 6, over the adjacent being negative 5 again. So it's important to realize that in this quadrant, anything where we have a negative ratio for cos or tan will be an obtuse angle, or in quadrant 2. When we have positive values, for cos and tan specifically, they'll be in quadrant 1. And sine will be positive whether it's in quadrant 1 or quadrant 2. So we have to make those distinctions with a lot of the questions they're going to ask us on our homework today.